Hello, welcome to the Awakening Report. I'm your host, Doug Hamp. Pleasure to be with you again. We have a very special guest today. We have Monty Childs from the Safire project. Now, several years ago, I had him on my show, and he discussed just some phenomenal things. It really comes down to the question of the electric universe, this whole idea of a different model of the universe. The primary is a gravitational model, but there's another competing model, which is that the universe is very much comprised and operates on the basis of electricity. And so Monty has been working on a project now for several years where he is showing in the laboratory that it is possible to create plasma in the laboratory, and he suggests that the sun may be a plasma discharge rather than a burning gas gravitational model. I hope I got that right. Monty is the author of 3 college engineering textbooks and holds 8 international technical patents. He was lead design engineer of the Canadian National Research Council for rocket design to measure for oxygen in the upper atmosphere, and he's now the lead scientist and program manager for the Safire project. So, Monty, it's a pleasure to have you with us.
It's a pleasure to be here, Doug. It's good talking to you and good to see your face again. Just a couple of corrections. The National Research Council, it was really a contract that a corporation in Canada had. The National Research Council was working out some of the details with a company in Japan, and the Japanese had failed a couple of times, and then this company in Canada came to me and asked me if I would head up the design and engineering on the rocket to measure oxygen in outer space. And I worked with optical and electronic scientists to accomplish that. But it was, anyway, just to clarify a couple of points on there. And so and one other point, as far as the electric universe and electric sun hypothesis is concerned, that's not my hypothesis. Again, there's a group in the United States that I'd written a couple of papers and evaluation on their hypothesis and said that I believe that it might be testable.
Okay.
And that's what led into it, and they asked me to do further work. And at the time, I didn't realize that I was being interviewed for actually 2 years by this group, okay? I was like, okay, I'm doing a paper, I'm doing a talk, I'm doing this, and they're paying for my time in the hotels and the like. And then they asked me, we'd like to do this, and wanted to fund it.
That's funny.
Yeah. So what I should do is maybe back up. What we should do is maybe back up a little bit, and just maybe just briefly just explain what the electric universe, electric sun model is really about. The idea is that the sun itself is basically a positively charged body in a generally negatively charged environment. And anyone who Googles me or the Safire project will kind of see a basic explanation of what that's about. But fundamentally, it works on the premise that you have a differential in electrical potential. So as you walk across the carpet in the wintertime, maybe not in California or in Arizona or other places, but up here in Canada, that it gets quite dry, and your body becomes more grounded. And if you touch a doorknob, you can get a shock, and that actually is a plasma discharge. And it's because your body and the doorknob are at 2 different electrical potentials. It may be 100 volts higher than what your body is. And so that principle is universal. Okay, it doesn't matter if it's at the subatomic level or if it's at the macro level like stars. And the idea is that when you have this charge differential, one body is wanting to collect electrons while the other body is wanting to give off protons or ions. And that's the same way that, let's say, a fluorescent light bulb works. You have a cathode at one end, negative, and you have an anode at the other end, which is positive. And then when you fire it, all the atoms that are in that gas become ionized, and you get light from that.
And so, that was an invention of Nikola Tesla, is that right?
I don't know about the fluorescent light bulb, but or the idea that there's a charge differential. That's been going on long before Tesla, but he did a lot with it and made other discoveries with respect to, I guess you might say, the Earth as having a particular electrical potential, and other, and the universe around us, and did a lot of work with that. And to date, you might say Safire is very much related to that kind of work, although, how can I say this? You might say his work, Crook's work, Birkeland, many others' work is based on this charge differential, okay? And it's all around us. Our atmosphere is teeming with charged particles. Every atom in your body has an electromagnetic field. Every molecule, every cell, your heart, your brain, everything works on electricity. What's interesting is that modern, or you might say contemporary physics as it relates to the universe does not consider electricity as playing much of a role at all. They would look at electricity as being something that is responding to the gravitational forces. In other words, electricity comes out of all these collisions and compressions and things. And the electric universe, on the other hand, would be the opposite of that. They would say that electricity is the primary driver of the universe. And the evidence that we have right now in Safire is to elucidate, or you might say, shake out the model. We personally don't have a horse in the race in the sense that we want it to be one or the other. We really don't care. But in that, we can't find any disparities with the electric universe model at all. None. Zero. And that's really what's extremely profound. Because in Safire, even in phase one, we had a small ball that was about 1/4 of an inch in diameter. And we limited the power to 1800 watts DC, which is just a little bit more power than it takes for you to boil water in a kettle. But it developed its own stratified spherical atmospheres, as you can see in some of the videos that you find on the internet. We don't understand those things, but these stratified atmospheres, we wrote one paper on this that was published just last year. It's trapping the ions and electrons in these spheres. And this plasma is extremely hot. We figure right now we're estimating about 3,000 degrees. And that's just 1,800 watts. But the core of Safire is actually quite cold by comparison, maybe 300-400 degrees. We're seeing the same behavior with the sun. The further we measure into the sun, the colder it gets. The further out we go, the higher the energy states and the hotter the plasma is.
Isn't that cool?
Yeah,
that's just amazing. So it goes just against the traditional model that it's burning hot at the sun, in the center of the sun, and then it's getting cooler as you go out. Is that correct?
Yes, but what I'd like to say to that point is that no one really knows what's going on in the core of the sun, nor do we know what's really going on in the core of the Earth.
Okay.
See, there's speculation, scientific speculation, based on what we see going on, and people think that, okay, well, it's got to be compressive and it's got to be a hot core. But in this particular model, the hot core in a plasma, because the core of Safire is hot, but it's not millions of degrees.
Right.
It can be hot, and plasma does do that. And it's the only phenomena in nature that has that particular characteristic. It's almost counterintuitive. You'd think the closer you'd get, the hotter it would get. And I think that can drive people to think, well, the sun's core has got to be much hotter. But plasma doesn't work like that. It's got very unusual behavior, and it is a natural phenomenon. It's not man-made. See? And we see the same behavior in Safire. But further to that, this intense ion cloud, which is really the stuff. The ions are the protons, and they're the heavy stuff. They're the stuff that's really what we're made out of, okay? There's a cloud that built up around Safire, and it would blow off into the chamber like a CME blows off into the sun. And when it did this, even at limiting the power to 1,800 watts, we measured surges, not just spikes, but surges, which lasted for a short period of time, but maybe 250 nanoseconds, which is short, but it was still a duration. But the power that was coming out of Safire was over 10 million watts of energy. which is more than most nuclear power plants produce out of a ball that's only 1/4 of an inch in diameter. And again, like, where does this energy come from? So we're phase 2 now. I mean, the reactor is by far many orders of magnitude much bigger. You could probably stuff maybe 10 of you in there. Okay.
I'm just sharing the screen here with everybody so that they can see.
Yeah, that's phase 1.
This is phase 1, and that little glass thing you're looking in there, little glass bubble there, and the inside is the anode, right? And
Yep.
that's what's creating the plasma. And you're using 1,800 watts, did you say?
Yes.
That's about the same as my hair dryer, right?
Yes.
Not that I dry my hair, but as a household hair dryer is about that. 1,200, 1,800 watts is what you get. So
Yes.
you're able to inject that much power, and this is just here in phase 1, and that is producing, and you're getting more energy out of it. Did you say? Did I hear you correctly?
At times, we don't know that it's an aggregate. In other words, we don't know that generally there's more power coming out of it overall than there is going into it. It could be acting like a capacitor in some way. We don't know, where it's storing the energy and then releasing it very quickly. But that picture itself, yes, that's my last talk. Perfect. So that picture that you saw in phase 1, the discharge itself, actually, that might have been one of the times that we would have seen these right there. Okay, just stop for a second there.
Okay, sorry. Let's see.
Go back.
Yeah, I was looking for that discharge because I remember seeing that. That's pretty impressive.
Yeah, you just had it there a minute ago.
Was it right there?
Yeah, there's one. Yep.
Okay.
So when you see this bright flash, there's a lot of energy being released at this point in time, and like 10 million watts. So
wow.
Anyway, we were measuring anything from 2 million to 12 million. So average, I would say maybe 8 million. Okay, that's a lot of energy, and it didn't boil anything in a sense. It didn't melt the core at all.
Right.
But further to that point, when you see these discharges happening, we had computers in the lab about 20 feet away, and they were unplugged. But we had a small thumbnail drive in there, and it's flashing on and off. So we're getting electromagnetic pulses as well that we couldn't. They were so high that we couldn't actually measure them.
Wow.
So we did not expect any of this. I mean, we thought, okay, there's going to be some kind of a glow discharge, and that's about what we kind of expected to see, but we didn't expect this. And we did. Okay, here we are, right here in phase 1. You're
okay.
Moving pretty.
I'm trying to get there. It's a little tricky. I can. There we go. But then it kind of just disappears.
There you go. There. Okay, so that's a nice close up.
Yeah. That's phenomenal. I mean, that is just phenomenal. And so one of the possibilities, you don't have a dog in the race here, but it could be that the sun is acting like the anode, and it's that positive. Is that correct? It's a positively charged thing in a negatively charged universe, and there's a electrical differential that's happening here.
Did I lose you there?
No, I'm still here.
Nope.
I'm still here.
Okay, sorry. Go ahead.
So basically, this is creating, potentially it's creating that the plasma is what we're possibly talking about.
Yeah, what you're looking at right there. Don't go too far. Just leave the picture on there. You'll see where it's very bright in the center there. It's kind of a elongated shape, and then you see on the other side where the cathode, the ring there. That whole environment outside of the very center is negatively charged. Okay. So what you're looking at here, the bright spot, actually those ions, that white cloud you see right in the center is a cloud of ions, and they're heading towards the cathode, but it's not an arc. Okay. It's not like a lightning bolt.
Okay.
And so imagine this for a moment as being a massive, like if this was a bazillion times bigger, something like this coming off the sun. I mean, it would basically fry the Earth.
Right. And
pretend the Earth is that little white ball towards the bottom.
Okay.
So the energy is heading out from the core out towards the outer regions. Okay. And that light cloud that you see around that, actually that gas is generally hotter. Okay, it can be hotter.
Wow.
Strangely enough.
Yeah.
And the further in you go, the colder it is. You can't really see the core right now, but because it's obscured by the amount of light that's coming off of this.
Right. Yeah, it's incredible. I was trying to get to one of these arc.
Okay,
So
here's another one.
yeah.
So these, even though this looks like a flat pancake with all these layers, actually plasma is translucent. And you're really looking at the kind of horizon or the tangent of these spheres. These are actual round spheres.
Wow.
Okay. And they're all rotating around in many different directions all at the same time, moving very fast. And so these are these stratified layers we're talking about, these stratified spherical, we call them striations, okay, in scientific terms. But that's really what we see going on here. And in each one of these layers, as you can see, there's kind of a dark region, then it gets brighter again. The electrons and ions are being trapped here, we think. Okay, this is what we're investigating. And so we may have created a star in a jar. We don't know yet, but we have evidence that's kind of pointing in that direction. But we, the actual mechanism or the processes by which these things occur is just based on charge differential, and that's it. I mean, there's some other things I can't talk about right now because of
right. The Men in Black would show up, and you'd have,
Well, I met some of the Men in Black, actually.
They exist, huh?
Well, they're not really dressed in black. They actually, some of them are pretty nice guys, and they have, concerns for America and for, liberties that we enjoy here. Well, somewhat eroded over the last number of years or whatever, but they have certain concerns, and and I'm on board with that. Like, I understand why we can't. It's just not wise for us to let certain information out.
Fair enough.
But it is getting out, okay, and it has to be get released in a way that is healthy, you might say.
Right. Absolutely. Yeah. So now, why did you need to go from phase 1 to phase 2? Why did you need to build a bigger, star in a jar? What was wrong with just kind of sticking with what you had?
Well, what you're looking at in the small bell jar is what we call qualitative observational science, which is nothing wrong with it, but you can't really gather much information from it. You can do certain spectral analysis, or using cameras do certain basic types of analysis on it. But in a much bigger chamber, what we can do now is put in probes that are specifically designed to measure the characteristics of the plasma. The electron density, their energy states, the ions, the flux, just a whole slew of things that kind of tell us a story about what is really going on in there, and might lead us to understand better why these double layers form, which might give us some insight as to why the atmosphere and the sun has various different layers. The same thing with the Earth. The Earth has various layers in its atmosphere, and they're very distinct. We have an ion, an ion layer. We have basically the atmosphere that we breathe, but there's different layers through every planet, actually, whether it's, Jupiter or the Earth or Venus or the sun. They all have these stratified atmospheres, and it'll give us some understanding about what's going on there. And, one of the most obvious things with Safire is to understand better how God really created the universe. And maybe we can learn something from the sun, and maybe if we understand how it works, who knows, maybe we can recreate a star in a jar and obtain energy from it.
So I pulled up a picture of the sun.
Yep.
And maybe you could point out some of the similar things that you're seeing in your star in a jar as we actually see in the sun.
Well, basically, right now, what you're looking at, if I showed you a recent picture in phase 2, you'd be hard put to really tell the difference between what you're looking at right there and what we see in Safire.
Okay.
It's that intense.
Wow. All right. So everybody, this is the sun right here. This is a photo of the sun. All right. And based on the plasma electric model, it would be presumably plasma or electricity that is creating this kind of effect. I'm going to actually go to that because you have a place there in your video, and I wanted to just show everybody, and so that we can actually do a little compare here. Let me just pull it up really quick to takes just a second. There we go. All right. I'll share the screen, and then we will get back and take a look at that, and maybe you can do us the honor of helping us figure that out. So I think it was toward the end here of the video, because you go into a lot of very, um, interesting things as to how you get there, how you get to these different phases and all the fabrication, and it's pretty cool stuff. But I think maybe for this purpose, we will just kind of get to the right to the point here. So this is maybe not the best one, but this was let's see here. Maybe you can stop me when you, because I think it was toward the very end where you did that big aha moment, which is pretty cool. Let's see here. And
go back
a little bit here.
Yep, further back.
Okay. I guess I'm a little. There we go. Okay, I see it. Here it is. Okay, there we go. All right. So this is in the laboratory. This is what you guys have done. This is an anode that is inside that vacuum chamber, which is about 5 feet in diameter. Is that right?
That's about 4 feet in diameter. It's about 7 feet long.
Okay. And so this is the cathode inside that chamber.
That's the anode.
The anode, excuse me. Yes, the anode. Sorry about that. Yeah, so that's the anode. And so kind of give us just a basic summary of what is happening here and how you were able to do this.
Well, like I said before, it's a charged differential. So the anode is positively charged, and what you're looking at, the light that you see coming from that are atoms that are in the gas, you might say, that we're using at the time, and they're ionized. So when an atom becomes ionized, it emits photons. Okay, the electrons get further out from the core, and then they're trying to get back to the base state, and they start to emit photons. So all the light that you see is from that. What you're really looking at, believe it or not, even though the center looks brighter, the certain striations that are just starting to form away from that, if you look closely, looking at your screen, a few millimeters away from the what looks like the surface of the anode, you can start to see a halo around that, and then further out, it's more orange. These are some of the higher energy states of the atoms. They're actually higher temperature than what the actual center is, believe it or not.
Wow. How are you able to measure the inside of that anode? I mean, that's pretty incredible.
Well, we do have instrumentation now in phase 2 because it's a much bigger chamber. We can mount them on the side of the steel chamber and then bring the probes in and measure through these different atmospheres. That's the gimbal that you may have seen, and it's like a long needle. There's even a video of it someplace.
Yeah, I wanted to show people just so they can get an idea of what this thing looks like. Let's see if I can find. That's part of the. Let's see. Hold on.
As you can see, I don't wear a suit and tie all the time.
That's all right. We wouldn't expect that. You're a working man. That's good. Come on, where did that go? I know. Let's see. I don't know the presentation like you do, but let's see. So this is the people can't see my mouse here, but so this is your main chamber right here. It says that we can see.
Yeah, if you keep going further, what I could do here, I could maybe pull up.
Yeah, you're welcome to share your screen as well, and then you can be at the controls here.
Yeah, I'm just gonna look for a couple of things.
Okay. Yeah. So what I think it's just incredible research, and I'm so glad that you guys are doing this because, for me as a biblicist, as a biblical scholar, researcher, I get excited about this kind of stuff because I think creation is awesome. And like you said, is it a gravitational model? Is it an electric model? It doesn't necessarily, impact our world dramatically today, but I think it becomes very interesting, and I believe, and this is just me talking as Bible guy, that the electric model seems to fit much better with what the Bible suggests. I get excited because if you look at what it says in Ezekiel chapter 1 about God's electricity, that God It says
Yep.
the word chashmal, and that he literally has electricity coming out of himself. He is that generator. He's the producer of the electricity.
Yep.
He's the source of it. And, so I guess I would kind of see, God as being the ultimate source, and he's holding all things together. And that energy is literally coming from him, and then it's radiating out to the entire universe, as it were. So
Yes.
it makes a lot
And
of sense.
well, from a science perspective, I don't have enough faith to be an atheist. Okay. I look at order, and when you say, I think you use different terms, but we know a basic precept in science is that order does not come out of chaos without intent. And even those who may be agnostic or whatever their perspective is can recognize those things. So that in itself defeats the idea that somehow there's a Big Bang explosion and all this order that we see around us came out of this chaos. And that just goes against a number of laws and thermodynamics and so many other things that we observe in science. So the order that we see, even from a basic level, is by intent. There's no question about it. It doesn't happen otherwise. So there's no question in my mind right now that God created the heavens and the earth. Now, as far as time is concerned, because of what we see going on in Safire, anytime someone uses this says it took billions of years, really what they're saying in effect is that they don't know what the processes or the factors involved are, or how they interact with each other for something to come into order. So time really doesn't have any place in science until you've identified the ingredients, you might say, or the factors involved in the process. And then you can say, okay, well, it takes a certain amount of time for these things to respond to each other. And then you have a response, okay? So in evolution, as an example, there is no process by which order is coming out of chaos. So they'll just say, well, it's billions of years. And immediately the whole evolution is it's a concept. That's all it is. It doesn't even mature to a hypothesis, let alone a theory. And they claim it to be theory. And the word theory is kicked around today. A theory is something that you can apply, like Newton's theory in gravity. I mean, we use it all the time. That's a theory. Pythagorean's theory in mathematics is an example. So those are theories because they've been demonstrated, proven that we can use them and work with them. Prior to that, it would be a hypothesis that needs to be tested. And if it's untested, it just has to remain as a hypothesis. And it may be untestable, okay, at least at this time in history, which still doesn't mean it's a theory. So people claim theories, but they're not. They just, they're not. They have to remain as either a concept or a model of some form. And so as far as the creation of the heavens and the earth, I really have no issue with it. And personally, right now, I have no issue with 6 days.
Wow.
It's an order of magnitude. The amount of energy associated with it. Think of it. A 1/4-inch ball, 1,800 watts, releasing over 10 million watts of energy. That's huge.
That is phenomenal.
So when we consider the universe and how much energy is out there, we see matter coalescing in Safire in nanoseconds, billions of seconds. It's not like millions of years, it's billions of seconds.
So this electric plasma model really shortens everything. It takes it from the need for billions and billions of years and really takes it down to, as you're saying, a very, very short time, in the matter of seconds or 6 days, as it were, right?
Well, people that are into electricity will know about what's called an electrical pinch. And what it does is basically that's what Safire is. It's a pinch. And a pinch means that it's drawing matter into its core. And when that starts to happen, it happens very fast. And then it starts to build on itself. So as the particles come into the core of Safire, they become positively charged and then it starts to grow. So what I'm going to do here, I don't know if you can, I don't know how to share my screen here. I'm going to show you a picture. Do you know how to do that?
Yes. And so what you're going to do is just go up on the left side of your screen. There's a green button, and you'll see it has a green screen. Yep, and that's it.
So then, Pick the screen.
And you'll need to either do full screen or your application. So you may want to do your application screen.
Can you see this one?
I don't see it yet. No, unfortunately.
Share screen.
Yeah, you're getting there. Make sure you have to get the right application window so that, okay, I see you again. I don't see your screen. I'm sure you'll get there.
Well, what I'm going to do is I'll bring this over to this. I'll bring this over. I do engineering, so I've got three screens.
There you go.
Okay, give me a second here.
Yeah, sure, of course. Right.
Okay. Share. Start sharing the screen, and now I will share.
That's awesome.
Just bear with me here.
Yeah, of course. And while you're doing that, I'm going to actually share my screen really quick.
You see this now?
No, it's still black, unfortunately.
Really?
Yeah.
That's really strange.
It takes a little practice, especially when you have multiple screens. But here I'm just showing a pinch in plasma so that people can see what that generally looks like. Is that kind of what you were thinking about when it comes to a pinch?
No.
Okay.
No, that's a Tesla coil that you can see on here.
Okay.
Yeah.
Okay.
The behavior is the same in a sense of what's going on there.
Okay.
So I'm pushing it.
I'm sorry. Go ahead.
I'm pushing the green button here. But
okay. So you hit the green button, then it'll bring up a little thing that says share full screen or share an application window, and then you go to the application window and you have to choose which picture or window you want to share. So that's how we do that.
So it says here, I see your screen. It says full screen 1, full screen 2, full screen.
Yeah. So figure out which screen that's on. But
yeah,
I would.
I okay. Start this. It's really strange. It's not.
Technology doesn't always work, does it?
No, it doesn't. It sucks.
I know it does. Now, does the sun also have a pinch? Can we? The sun?
Well, yes, that's right. Exactly. So what we're measuring is spacecraft, because what I should do is maybe let you know who's on our team.
Okay.
So we have James Ryder, who was the vice president of Lockheed Martin Space Program, who developed the SDO spacecraft that actually gets the pictures that you've seen of the sun earlier. Right. It was his team that developed the spacecraft and had NASA launch them, as well as, so that's SDO. There's AIA, there's IBEX spacecraft. So he's on our team. Okay, so that's one guy that's on our team. Okay. Another guy by the name of Dr. Lowell Morgan. He worked at Los Alamos and Livermore Laboratories in nuclear and plasma physics on part of your nuclear weapons program. Okay. Dr. Paul Anderson, who is actually your United States Department of Defense. He's one of your top scientists working in chemistry. He's a chemist. Dr. Michael Claridge, who is an astrophysicist. He's out of Boston. Just a number of people like that. Okay, so this is not a garage experiment, and it's being funded by the International Science Foundation of the U.S.
Wow.
So there's Americans and Canadians that are converging on this, and others that are like Walt Thornhill out of Australia. And so I think it's important that your viewers know that this is not the Monty Show. Okay, this is
yeah, of course, right,
around the world, and
yeah, it's a lot to make all that happen. Yeah.
Did my screen ever come up?
Well, I was just sharing my screen, so I wasn't actually looking at your screen. But no, I see your picture, but I don't see your screen.
That's too bad.
I know that's a bummer. Sometimes it takes a while to figure that out. I don't know if you can see my screen. I'm sharing here a picture of the sun, and is this thing that's coming out from that? That's I forget what they call that.
That's coronal mass ejection.
Okay.
Okay, so that's actually plasma stuff. Those are ions. That's stuff. Ions. When we talk about ions or protons, that's actually the stuff that our bodies are made out of. Okay, or all the stuff like those are not electrons. I mean, although there's light coming from that, and the light is due to the electrons working with the atoms and to give off light. But that's actual stuff. I mean, that's a coronal mass ejection. It's highly magnetic in nature. It's extremely hot, and when those things get released, there's a lot of energy there. The Earth you can see there's a small scale of how big the Earth is relative to these things.
Right.
And actually, it's one of the things that when I was down at I was invited to be to go to the American Philosophical Society, which is really the Ben Franklin Institute in Philadelphia. And there's a number of scientists that are connected with NASA. And one of the big concerns is that if the Earth is in the path of one of these things, when it gets released, it'll basically it releases a massive electromagnetic pulse that lasts for days. We're not talking about something that like off of a bomb that's released by an enemy. We're talking about something that would encompass the Earth for a number of days and would basically fry our electrical grids around the world.
Wow.
So, steps. The conversation's out there. So the idea is behind it is making plans that in the event that something like this happens, how do you recover from it?
Wow.
So this is what we call heliophysics, relating to the sun. And so it's a part of what research we do to better understand what kind of things are going on in Safire. And I wish I could really show you this picture.
If the sun is a plasma electrical system rather than a gravitational system, as is traditionally thought, and if what we see from the sun, that you have this huge amount of magnetism, do we also see a lot of magnetism being created in the Safire project?
Well, big time.
Okay.
Big time. I mean, there's a huge amount of electromagnetic fields in Safire. I want to share this picture with you guys. You are screen sharing, it says.
Okay, so what we need to do then for that screen share to work is you just got to find the right application window, and it's probably, since you have 3 screens, it's probably making it extra complicated because there's different places to pull from.
Okay.
Yeah.
Well.
Yeah.
Anyway, it's too bad here. Let me try something else here. I'm going to do this. I'm going to move this guy over here.
Yeah. So, and I'll just, while you're looking that up there, again, everybody, I just get really excited about this because, creation is something that's so important. And I believe that the enemy has really used the idea of creation. We can see that, by the way. He's used evolution to get us off thinking that, there's no need for God. But what I get excited, and the reason I wanted to have Monty, and again, one, it's just amazingly cool research, but two, I think that this is going to help us to understand creation better, to understand that God made it, and it didn't take billions of years for all this to happen, that there are different models, and we just have to keep looking, and the answers are out there. And I think that Monty and his team of Safire, these top scientists from around the world, are really onto some amazingly cool stuff. So, yeah, we can see that now, and share with us what you got there.
Well, and as an example, okay, I've just stopped the video here. I mean, this is a bit rough because it was one of the cameras that we're looking at. We were just doing some preliminary startup, okay? And what you see here, again, is these double layers that are occurring around the core. The power setting here is extremely low. To give you an indication, we're talking maybe 200 volts and maybe 200 milliamps, which is not a lot.
Right.
Okay. Of power, but the size of this plasma here is actually reaching out the full 4 foot in diameter plasma. The whole chamber is actually full of this plasma under such low power setting. Okay, which is quite remarkable, actually. So you can see how bright it is here in the center, and as we go along, it's pulsing. Okay, you see right here in this picture, the bright yellow discharge. This would be like a CME that's coming off the core here.
Okay. All right.
Now the core itself, it would still, like, if the camera was able to differentiate, or what they call dynamic range, there is light coming off the core here. It's just that the light's so bright here, it makes the core look like it's dark. Well,
okay. Kind of like in the sun, right?
Yeah.
Yeah. Okay.
So that's when we see some of these discharges. And actually what you see here is one of the probes that we're actually bringing in here, and it can measure the electrical properties. We can do optical spectroscopy to measure the various optical characteristics, or every element in the periodic table when it's ionized has a very unique light signature. Okay, it's just okay, and so then we can measure the properties of the gases that are in there. So we can move this probe around in three-dimensional space inside the chamber, and so as you can see here, it's just blowing off. And I'll just play it. That's a very intense discharge right there. I mean, this is an ionizing discharge. The amount of energy in here, we don't know right now, but it can be extremely thermally hot. It could be a few thousand degrees right now, or it could be 100,000 degrees.
Wow.
But because they're short-lived, they don't vaporize the chamber. But if we left them there, they would start to eat the chamber walls. Wow. So we have to be somewhat careful.
Right. Oh my goodness.
Okay.
That's incredible.
So we're just starting up right now, and we're trying not to vaporize.
Yeah. What you just built.
Okay, that is a real concern of ours.
Right.
But to get back to what you're saying earlier in the scriptures, because I think this is really important, I really don't have any issue from the very beginning of Genesis right through to Revelation, the claims that are made there. From a science perspective, my view on right now is that if you have testimony, accept the testimony as it is, unless you can define proof to show that the testimony is false. So right. I have no reason, there's no evidence to say that the earth and the universe was not created in 6 days. Wow. Other than the people's lack of understanding of maybe how it came into being, doesn't mean that didn't happen. See?
Right.
And when I read through Ezekiel like yourself, and I read, the words amber and other words, all the testimony about God's throne is all this energy and light in every testimony, Old Testament and New Testament.
Right. Yep.
There's things that just blow my mind, okay? Because I'm trusting I'm speaking to an audience of Christians, which I don't very often have the opportunity to do.
Yeah.
Well, I can't, like I'm under contract, so I can't talk about these things here in certain environments, because that's my job. I'd be violating that trust, because my job is to do the science, and here's the reports. Okay, so there's things that happen. So when Jesus rose from the dead physically, a lot of people can't get past that and say, well, it's impossible. I don't think it's impossible. There's testimony, and many people say that it happened. So I accept that. But what further really just blows my mind is that on the day that he was taken up into heaven, and the angels are standing there, and they're talking to the disciples and saying, why are you looking at this Jesus? He will return in like manner. Now, often, I've been a Christian since I was 18 years old, and we go over this pretty quick. And it says that Jesus' body was transformed, and now he sits at the right hand of our Heavenly Father.
Right.
Okay. That's pretty remarkable, because it means that his body left this physical earth in a physical shape, in his physical body, and at some point between leaving this physical earth and going to heaven, his body was transformed from a physical state into what appears to be, from the testimony in Revelation and other places, to this extremely high energy state we hear from John. All this light and energy when John's starting to, tell us what he's seeing in heaven. So what that tells me is that, well, if I went back further a little bit about the testimony about angels, 1 minute they're here, the next minute they're gone. 1 minute they're in heaven, and the next minute we could be entertaining angels unaware. So there must be some, you might say, God's technology for these beings that are in heaven 1 minute, for them to be in a particular state, and then coalesce to the kind of matter that we see as human beings into this particular state where we can see them. You see?
Yeah.
So there is a transformation of matter, which is what plasma, plasma, they call it the fourth state of matter. I personally think it's the first state of matter.
Ooh, that's interesting.
Okay.
Yeah.
Because it comes out of God, like He is the energy source. He, like electricity. We don't know what electricity is. What you're seeing right now on the screen is matter responding to electrical energy. See, it's responding to this energy that is in the universe, and we just created a charge differential. But what you're seeing here is not electricity; it's plasma, and plasma is the stuff, and it gets excited, and it goes and it shows all of this light and energy. But really, that's still a secondary thing. The electricity is there beforehand, if that makes any sense.
The electricity is there beforehand.
Oh, yeah, the energy is there beforehand. What you're looking at here is atoms and protons and like ions, because ions are just energetic atoms. Right. They're responding to the electromagnetic force that's in that chamber.
So we're looking at the effect, not the cause. Is that correct?
Yes. Okay. You're looking at the effect, not the cause.
And we don't understand what the cause is. That's what you're saying.
We call it electricity. We can see what electricity does. We can spin magnets around and they generate an electromagnetic field, and somehow electricity is created and we pump it through wires, but nobody really knows what electricity is. We call it electricity and we use the word every day. It's an electrical outlet, or it's an electrical, the TV works on electricity, but we don't know what it is.
So I guess that's really interesting. I mean, it's amazing to hear you, who are very well versed in all these things, to say that we don't know what electricity is. I thought it was just the moving of electrons through a medium. That's not correct?
Well, no. What you're seeing in effect is the response. That's not the cause of why the electrons move.
Okay. So what you're saying is we don't know why the electrons move in the first place. That's the point.
Well, they move because there's a difference between the negative and the positive, and we make it go through a wire. That's how it works. But we don't know what electricity is. We see its response. It moves electrons. It causes plasma to ionize. It causes light bulbs to warm up, and like incandescent light bulbs to warm up and heat up because of the difference between positive and negative, and the material that's inside will get hot, and it starts to it's called thermonic radiation. So it starts to radiate light. You see. But we don't know what electricity is. We can see it, and we can use it, and we can use it as a tool, but we don't know what it is. And it affects matter and these things in all different ways. And what you're seeing right now is really the most basic response of matter to electromagnetic forces. So this is how atoms, when they're broken apart, this is at the very atomic level. So if you were able to zoom right into that light, you'd see all these independent atoms. They're not molecules, they're atoms spinning around and doing their thing. They're broken apart, and you're really seeing at the atomic and subatomic levels what you're observing here on the screen right now. Wow. So, yeah.
This is blowing my mind. I love it.
It's blowing my mind, Doug. And so we are privileged guys. You'd be surprised how many Christians are on this team. Wow. And God has appointed certain individuals to work on the Safire project. When I need a particular person, they're there when we need them. Need that person to be working on, on the project, whether or not it's data acquisition, or whether or not it's physics or spectroscopy. And I'm so privileged personally. We get to examine God's handiwork at this level. Wow. And who knows? I mean, if we do create a star in a jar, and if we do end up getting more energy out, then it's actually going in as an aggregate. It would be God's gift to humanity.
I mean, let's not gloss over that, because that's really huge. If you can have more output than input, you've just created another kind of power source, haven't you?
I don't know. We've created another power source. We may have come to a place where we understand maybe how the sun works.
Well, I'm just thinking of practical applications. If you have something that's putting out more energy than it's taking in, could that not potentially be harnessed to,
I struggle with it a little bit in the sense that we're putting, it could be that it's transforming energy. Okay. I don't know that we're getting more out than in.
Okay.
It could be that it's releasing potential energy, you might say, that's already there.
Okay.
If that makes any sense.
Okay.
So like a stick of dynamite has potential energy, okay,
Right.
example, and you don't really see it until you light it up.
Right.
So there's certain catalysts, catalytic events that occur in nature all the time. And once it's set off, it'll start to, cause other reactions, okay?
Okay.
And we do get copious amounts of an atomic mass of 3 in there, which we don't put in there at all. And anyone who is involved in physics at all would understand what I'm saying, which is pretty radical. But we don't care. We want to make sure that we do it right and we don't get hurt either, right?
Right, sure.
So atomic mass of 3 means it's either doubly ionized hydrogen, deuterium, tritium, or helium-3. And the only thing we're putting in the chamber right now is hydrogen. So if we're getting these other elements, then there's a transmutation of elements, which goes on in nature, and it does go on. And this is what cold fusion research has been about.
Huh.
It also means, too, that if this is the case, you don't need nuclear weapons to cause things to fuse. And there's a basic principle, and it's true. It's called the Coulomb force. It's the strong force that why atoms themselves cannot be just pushed together. They have to be smashed together to pass that force in order for them to fuse to create a new element. But there's a lot of evidence, a lot of experiments that have been conducted that it doesn't have to happen that way. Now that means that for elements to transmute or become heavier, let's say we go from hydrogen to helium to deuterium, or deuterium, and then we get into heavier elements, ultimately into lead and some of the heavier elements, that they actually get married, you might say, under certain resonant frequencies. And that may be what's occurring in Safire. That if we're getting these elements, the only reason why they would be occurring is that if they're resonating at certain frequencies and they get married. And when they do, they release a lot of energy. You see. And
wow.
So for me, as a Christian, it just blows my mind that, when you have this process occurring in nature, it's not a matter of time. It happens very fast. And you get heavier elements very fast, and they grow, you see. And this is known. This is, even in the contemporary physics, this is known to occur. So, can you make gold? Yes, ultimately you can under the right conditions. Maybe not in Safire, but can it be done? And the answer is yes, it can. Or any other element. That's how new elements are created. Like you see, the periodic table keeps growing, after year after year. And there's certain non-collisional, non-kinetic types of experiments that are conducted that we do get new elements from. So, wow. And that there in itself flies in the face of all this, gravitational kinetic model, which actually is based on Darwin and Lyell, who is the grandfather of what we call modern geology. But I could go on about this for a long time, but as an example, uranium, has a certain half-life. I forget how long it is. I have to look it up. But if uranium came out of the Big Bang, and if the Earth is really like 4 billion years old, or however old they say it is, uranium actually, over this period of time, shouldn't be radioactive. It should be just dead. That's it. Okay. But it is. So how did uranium even, how is that we mine uranium? How is it that's even there in our Earth? So that in itself indicates that the Earth is actually relatively very young.
Wow, that's really cool.
Yeah, it is cool.
What do you think will be the bigger impact, if as Safire goes on and you're basically able to prove that this is, assuming that you could prove that this is kind of an electric model, what implications do you think this will have for the Big Bang Theory and creationism in general?
Well, Big Bang is over with. You talk to any of the people, even the guys at Lockheed in the space program, we know that the Big Bang Theory is just, we know it's a bunch of junk. Okay? Already. We know that modern physics, contemporary physics, as it relates to cosmology or how the Earth and how these things work, we know that it's in deep trouble because like the phenomena that you're seeing on the screen here, they can't explain why these things occur. There's just too many disparities with their model. So it's just a matter of people talking about it and exploring that maybe electricity is really what's driving the universe, not gravity. The electric force in nature is 10 to the 40th power stronger than the gravitational force.
Wow.
So
People, that's 40 zeros. That's a number with 40 zeros. That's a huge number.
So why is electricity why doesn't it play a part of contemporary physics? It makes no sense to me at all, personally.
Yeah. It is one of those weird things that's been going on. By the way, uranium is 4.47 billion years is their half-life. So it's
right. Okay, there it is. So if you had the universe 14 billion years, why is uranium? I mean, why is it still radioactive?
Yeah, good question.
There you go. So it doesn't. So there's these kinds of obvious disparities. Okay, we know, like Einstein. Okay, I don't want to get on Einstein because some people like as an engineer, I really don't care. E equals mc squared. Okay, so c in the equation is the speed of light. But we know, and anyone can Google this, that the speed of light varies. So therefore, immediately the equation is wrong because it's in there as a constant. It's, and we don't even know what mass is. Mass is a response to gravitational forces. But we know the gravitational force itself varies, and, we don't know what mass is. So I can't, his equation itself is good for maybe people that want to study theory. But our team is do what's called applied physics. We actually build stuff and test it. We don't theorize much. Okay. If we put a theory out there about something, we need to go and investigate it to see if what our hypothesis is it true or is it not true.
Yeah.
So we're the purists. When we walk into a room, and I've seen it happen, the theoretical guys usually start exiting the room. You'll say, okay, well, look, let's examine your hypothesis. Okay, let's see if there's some substance to it. Can we test it? Let's see.
Yeah.
And
that's funny.
Yeah, just give me a second here. I'm in an interview here right now.
Yeah, that's too funny. Wow, that's really amazing, and it's so important. It really underscores the importance of doing the actual experimentation, because that's when you weed out the guys that are just thinking big thoughts. The armchair quarterbacks, as it were.
I call them like the Wizard of Oz. They're like they're pontificating great prognostications, and never mind that man behind the curtain. Just listen to what we're saying and believe what we're going to say, because we're going to define who you are and how you came into being.
Yeah.
And I really struggle with that because science can only examine nature as it is right now. It can't tell you who you are. What it can do is explore nature, and that's what it does. And we can get technologies that are beneficial and improve our lives by it, but it can't tell you who we are.
Yeah. Yeah. Well, that's interesting. That even the theory of relativity is very, very relative to the very factors that are going into it. So if the constant of speed of light is not constant, then, like you just said, that disqualifies the whole theory. And
light itself,
mass as well. Yeah.
Light itself is a response to something that occurs before you see light. So there's a force in nature that is occurring on an atom to cause the electron to get pulled away from its core before light is emitted, before it's emitted. So electrons and light is retarded. In other words, it's latent. It happens after the particular effect, or it's an effect. It's not the cause. There's something else going on long before you even see light.
Which you go back to Genesis chapter 1, right, and you see that the Spirit of God was hovering over the face of the deep, right, and that word there, merachefet, is to infuse with some kind of a vibration, and then God says, "Let there be light." Right?
Yeah.
So
when I read that, man, I am blown away because I see it happening in Safire. This stuff is already in the chamber, and it's not until we introduce an electrical field in there does it all come alive.
Wow.
And so God has, in His mercy towards us, has allowed us to be able to manipulate this electricity to observe these particular behaviors. But this goes on. Those atoms that you see that are all lit up right now, they're already in the chamber. If I cut the power, it's just going to be black. But the moment I allow electricity to come into it, we see this response, and this is what we're getting. So I would have to say that, yes, God does sustain the heavens and the earth and the sun, and by the word of his power. And word, when I hear the word, I think of vibration and I think of harmonics, because when we use words, we're, vocalizing these things through the atmosphere, and they're going through these electronic devices, and you hear it at the other end. These are vibrations and resonances that we pick up with electronics, and then we transfer them around the globe, and we can hear each other. And so by the word of his power, he puts things in motion. And when you have motion, you have electromagnetic fields, and when you have electromagnetic fields under certain conditions, it generates light. And these are the things that occur. And these are known principles in science.
Wow. That is exciting stuff. Well, by the word of his power, that I think that's such an important word for us, because, we tend to divorce God's word from all of that there is right now, and yet, when we start to think about his word, about the vibrations, about all these things that are keeping everything going, there you have it. So I think you've enlightened us so much. I want to thank you, Monty, for coming on the Awakening Report and sharing with us your phenomenal research. And where can people find out more about your research and just kind of keep up with what you're doing? I will publish your video so people can watch that. I'll put that in the comment section so they can check that out.
Well,
is there a website?
If they type in, and there's a lot of stuff on the Safire project. If they type in the Safire project, but it's spelled Safire, there's lots of information. It does come out kind of every 6 months. There's more stuff, once a year, because we are doing research, and we're not into daily publications. Okay.
Right. Sure.
Just don't have the time for it. We got work we got to do. So
keep on your work. We appreciate it. Don't take time to blog about it. But well, anyway, I want to thank you for coming on here. Everybody, stay in the word, because the word has the power, as Monty has so rightfully pointed out to us, that it's the word of God's power that is what sustains the universe. And so we're very, very grateful for all that he's done. And thank you for coming on. So everybody, stay in the word. Until next time, I'm your host, Doug Hamp. Thanks for joining us here on the Awakening Report.